everybody, welcome back to, let's see, what are we focusing on today? 7th grade expressions and equations. Wait, this sounds familiar. The first one I did for 7th grade was algebraic expressions and equations. Although this looks a little bit different. Let's see what we're looking at here. So I see some choose all. I can see a choose expressions equivalent. So that to me means you got to simplify, aka combine like terms. Oh, here's another one I said earlier. That one is special. Oh, there it is again. Okay, you'll see what I'm talking about when we get through these. All right. Another expression. Ooh, inequalities. Looks like we got to solve and graph. Okay, cool. More inequalities. Oh, man. Some longer. Okay, that's a lot of reading, but hopefully it won't be that bad. Okay. So now I'm getting my mindset and kind of know what I'm getting myself into. So let's go ahead and get started. All right. So what do we got here? Choose all expressions equivalent, aka equal. They're the same. So what have I said before, guys? The strategy here is just to simplify everything to all of this. So what do I mean by that? Well, first of all, it is a choose all, which means we're either going to pick 2 or 3 options. It doesn't make sense to pick one, or else it'd be multiple choice. And again, it's super rare to pick all of the options. Now, the other thing I notice is that this one, they both have 3 terms. That one only has 1 and 2. Okay, so let's see. Let's just do the work ourselves. That's usually easiest. So I got 10x's. I got negative 6x. I got positive 2x. So those are all my x's that I'm going to add and subtract. Then I got my units, aka just my numbers, right there. So I'm going to have 10 minus 6. 10 minus 6 is 4. 4 plus 2 is 6x. Then I have 8 minus 4. That's positive 4. So the strategy I have told you guys over and over is just to do the work for all of them. The problem with a lot of these questions, with the answers, is you're kind of expected to figure out like how the person making the test did their work, right? And this is what's hard for teachers. I'm just gonna be honest, because sometimes we're like, okay, how did you get to this step? And you're like, oh, I did this and this, and we have to think about it so that it makes sense for you, right? Whereas another student probably be like, I don't know how you did that, but yeah, we got the same answer. And honestly, that's what usually matters, especially to me, right? I always say, I don't care how you got there, right? As long as you didn't get lucky. All right, we got the same answer. So here's what I'm talking about. 6x plus 4 is my final answer. Is this 6x plus 4? No, so it can't be that one. I already see 6x plus 4, so I'm going to take that one. And this one, do you see what I'm saying? 18x, I don't see 18x's. So you know what? I'm just going to simplify each one of these myself and see if I get the same answer. So this one, I got 18x. Minus 10x is 8x. 8x plus 2x is 10x. So is that 6x plus 4? No. And then my last one, I got x's with x's. So that gives me 6x. Units with units, well, there's only a plus 4. So did that work? Yes, 6x plus 4. So do you see what I'm talking about? Just simplify every answer. Okay? Or option, I guess I would say. When you simplify all that, you should get the same thing. If you don't get the same thing, then obviously it can't be equal. Okay, hopefully that makes sense, the logic. Here it is again, same thing. People get frustrated with this because, oh, I got to go backwards and then forwards, and then they went sideways and then diagonal, and you get a headache. Well, here's what I know. That is done. Again, there's 4 options, so I'm going to pick 2 or 3. So what do I know about parentheses? To me, parentheses means I'm just going to multiply to everything inside the parentheses, aka distribute. So 4 times 4 is 16x. 4 times 12 is plus 48. 4 times 2, I'm different colors here. 4 times 2 is 8x. 4 times 4 is 16. Then I got 2 times 4, that equals 8x. 2 times 8 equals 16. And then 8 times x equals 8x. 8 times 16, I don't even know what that is. 16 times, and honestly, do I have to do that? It's going to be some big, ridiculous number, right? Can you already tell, is it going to be plus 16? No, it's not going to be plus 16. So can you already see what my final answers are going to be? 8x plus 16, 8x plus 16, 8x plus 16. That is not 8x plus 16, so it should have been that one and that one. So this is what I'm talking about, right? Like, I didn't have to think, oh, what did they factor out? Like, did you even know that that's what they did, that they factored out numbers and what they were different? See, it's less things to worry about, okay? Here's another example. So same strategy. Let's just simplify it ourselves. So I got x's with x's. I got units with units. So 5x plus x is 6x. 3 minus 1 is positive 2. So let's do each one. 5x plus 3x equals 8x, and then I have a minus 1. Then I have 4x plus 3x, that equals 7x, and there's no unit, so I'm done. Then 6x plus 2 is just 6x plus 2. And then I got 3 minus 1, that equals 2. And then plus 6x. So can you tell already our answers? What goes with that? 6x plus 2 and 2 plus 6x, because I could have switched it and said 6x plus 2. So those are my two options. All right, number 4. Choose the expressions equivalent. Again, same thing. So one thing we have hopefully realized by now is we got to be careful. If there's parentheses, or if there's a group, right, or a set of terms inside of parentheses, we can get rid of the parentheses if there's nothing on the outside. Technically, it's a positive number, okay, because there's nothing there, so it's just a plus, right? So this is just negative 1.2x plus 3.4, where we have to be careful if there is a minus on the outside. The reason being because we have to distribute the negative. So a negative times a positive is a negative 5.6x. And a negative times a negative will give me a positive 7.8. So in other words, when you distribute the negative, you switch the signs. If you do a positive times a negative, it doesn't do anything. It stays as a negative. And a positive times a positive is just a positive. That's why I'm saying it doesn't do anything, okay? So now let's see what we have. What do we got to combine? I see x's with x's, and I see units with units. So let's actually add and subtract here because I can't use a calculator, so you have to be careful. And let's think about it. I have negative 1.2x minus 5.6x. They're both negative numbers. So if I combine negatives, my answer can't be a positive. This is where you have to be careful. I hate saying a negative and a negative make a positive because you guys look at this and you see, oh, Beltran, there's two negatives. No, that is not a positive. Negative times a negative divided by a negative do make a positive. So you got to be careful. Stop saying a negative and a negative. It doesn't work that way, okay? Because of situations like this. So in other words, if they're both the same sign, I'm going to add those and keep it as a negative. So 5.6 plus 1.2 is 6.8x. Oh, look at that. They're both the same. So what matters is the numbers 3.4 and 7.8. So 7.8 plus 3.4, that's 2, carry the 1. 7 plus 3 is 10, carry the 1, that's 11. So I have C as my answer. Okay. All right, so this one looks like we did, what was the name of it? It was the one right before, not expressions or equations. It was equivalent expressions. It looks like these, remember? If you saw that video, so many of those. Okay, so same strategy. Enter the value of g such that the expression blah, 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 blah. So 5, 6 plus x in parentheses is equivalent, aka equals, to 5g plus x. So same strategy I've been telling you guys. Just work it out. So in this case, I see parentheses. That means multiply. In this case, distribute. So 5 times 6 is 30. 5 times x is 5x. On the other side, I see 5 times g is 5g. And 5 times x is 5x. So what makes it special is now I can see, hey, look, what does g have to be the same, to make both sides the same? Well, one of the things I notice is both sides have 5x's. So if both sides have 5x's, that means that 30 should be the same as 5g. So what's the last thing we got to worry about? Well, what does g have to be? So 5 times what equals 30? Or if you're solving an equation, we can say since there's a 5 stuck to a letter, aka your coefficient is the number 5, you have to divide by 5. If you do it to one side, you do it to the other. 5 divided by 5 does not cancel. Okay, it is not 0. That's what it means by cancel. It's 0. No, 5 divided by 5 is 1. That's what I want. I want to solve for 1g. So how much is the value of 1g? Because that's what I want. The value of g, 30 divided by 5 should be 6. All right, so hopefully that made sense right here. Okay. All right, this one. Let me just look at my computer really quick. Make sure I have the same things open. Sorry, I just want to make sure if I find any errors, I fix them while I'm still working on these. All right. Next problem. Number 6 and 7, they told me to use a calculator. Okay, I'm going to use it. Why not? Now, I've done one of these before. So let's see. And again, you've only known that if you've seen the other videos and if you did them alphabetically, I guess. So enter the value of x that makes the equation true. And I'm already noticing something, just like kind of like this one, right? Same kind of setup here. I see a 36 over 100 and a 36 over 100. So what do I have left? I know that then this one should be the same as that one. So 1.12 should equal x over 100. Interesting. So how do I solve for x? Well, remember, right, one of the things I tell students all from here until forever, right, it's how do I get rid of a fraction? Right? How do I turn it into a whole number? Well, the easiest thing to do, I don't care what it is, okay, you see what I'm talking about? You multiply by whatever's on the denominator, aka the bottom. So in other words, to get that x by itself, I need to multiply by 100. And if I do it to one side of the equal sign, I do it to the other. So if I do that, I'm going to put a 1 underneath as a fraction, because that's okay. And you know, fractions, when you multiply straight across, you're going to get 100x over 100. And again, most of your teachers would have just said cancel. No, they don't cancel. It becomes 100 over 100, just like 5 over 5, which gives me how much? 1. That gives me 1x. So on the other side, what do I put? Well, I had 1.12 times 100. So what was my answer? 112. Interesting. Do you see it right here? All right, what about the next one? Let's see if we can see a pattern emerge after doing a bunch of these. Well, same deal. I see 2 over 100 and 2 over 100. So therefore, I can say that this one is the same as this one. And in one of my other videos, I kind of did it the other way, where I was like, you know what, instead of multiplying both sides by 100, because that's how I can get rid of the divide by 100, I told you that the 46, remember back in elementary school, this was the 10, all right, and if you're at the front, your teacher probably spat on you because it's gross, but I mean, that's how I remember. And then the next one is 100, right? So this is 46 hundredths. Now it's x over 100 equals 46 over 100. Hey, look at the new pattern. The bottom is both 100. Therefore, x has to be what? 46. Hey, look at that. Interesting. But the trick is, right, if you see, essentially, because these are both over 100 and I have two decimal places, when I multiply both sides times 100, 100 over 100 gives me 1x. And then 0.46 times 100, well, guess what that's going to be? Just 46. So here's your quick mini lesson. I'm going to do this a bunch of times. So let's see, and I'm going to erase it. So 3.46 plus x over 100 equals 3.46 plus 0.34. So you're going to be like, hey, look, that one and that one's the same. So x equals 34. Again, why? Because it's this right here. And the other trick is, well, what if I do 1.5 plus x over 100 equals 1.5 plus 2.36? Well, again, I multiply by 100 because of that right here. So if I move it over, that's going to give me x equals 236. And that's your little shortcut if we do like a bunch of these, right? And that, again, I did this with my students, and most of them, or at least they were happy that they got this question because they're like, it was so easy, Beltran. We literally, the answer was right there. Okay? All right. So let me go ahead and delete this just because we're done with that. All right. So delete. So there's your little mini lesson. Let's go back to here. And I still got a calculator, so I'm going to leave it open. Marissa got $200 to spend at Disneyland. Wow, that's crazy. That's a lot of money. Okay, that ticket to get in was probably $200. She already spent $68. Okay, I see a bunch of numbers, so those are probably not important. She wants to spend the rest on Mickey ears that cost $32 each. Up. I see each. That means rate. Okay, automatically. When I see $5 per, every $5, $5 a, $5 and, that's a rate. So how many Mickey ears can Marissa buy with the money she has remaining? Okay, so let's work this out right here. Marissa has $200. She already spent. So if she spent it, you gotta subtract it. So I'm gonna take $200 and take away 68. So 200 minus 68. Now Marissa has $132 left. She wants to spend the rest on Mickey ears that cost $32. Damn, that's what? They're just ears. I don't get it. But again, I'm not a Disney person if you've seen my other videos when I talk about this. Ugh. Anyways, moving on. Okay. So how many ears can Marissa buy? So, let's think about it. If I have $132 left and each one is $32, well, I can do it very simply and say, okay, 32 plus 32 plus 32 plus, you know what I mean? This is the easiest thing for me to do because this makes sense to me. So that means every 32 is 1 ears. So I'm going to do a couple, okay? If I do 32 and 32, is that 64? Let me see, 32 plus 32. Yeah, that's 64. So that means that is 64. So what is 64 and 64? 64 and 64 is 128. So if this is already 128, can I add another ear? No, because I only have 132. And if I'm already at 128, I am done. Like, I can't afford another pair of ears. So at first I was like, is it going to be a perfect number? And I thought it was just because it's middle school. But right here, they're like, no, it's not going to work out. I have leftovers. So notice if I have 128, I have 132. I buy how many ears? 4 ears. That's going to be 128. I'm going to be left with $4. Does that even buy you a churro? I don't even know. Are churros $4 or are they more expensive? I feel like they probably cost more. Anyways, what's another way I could have done this? Some of you guys probably were thinking about this. You would have said, oh, I got 132, not 4. So you're like, I'm going to divide that by $32. So if I do that, that's fine. That totally makes sense. 132 divided by 32 and I get 4.125. So this is where you got to make sense of it. So that is how many whole ears you can get. That is kind of like your remainder, right? Remember long division, your remainder. So that's your leftover. So that's only a part of an ear. Can you buy a part of an ear? Can you be like, let me just take the right side? No. So then basically that's your max, right? That's where I said, right, you had $4 left over. All right, moving on. Number 9. So let's see. I always like to check a couple things. The first thing is that one is open. And that didn't really help me because all of the circles are open. So sometimes when I do is I check, and then sometimes it's like a 50-50. And you'll see, I think there should be an example like that. Otherwise, I'm just going to solve the inequality like any other equation. And this is going to be like a two-step. So what do I mean by that? How do I get rid of, and do I have a calculator? Yes, I'm going to leave it open. I got to get the x by itself. So how do I get that x by itself? I got to get rid of the 24 first. So the opposite of negative 24 is positive 24. Whatever I do to one side of the equals, or in this case the inequality, I'm going to do to the other. These do cancel because 24 minus 24 is 0. So I get 4x is less than negative 12 plus 24. And this is where you got to be careful. Just please use the calculator. Anytime I see minuses, I freak out. Okay, because stupid negatives until the end of time, even me as a teacher, I get freaked out because they always get us, okay, here and there. So negative 12, I have a negative 12. Then I have a plus 24. That gives me a positive 12. What's the last step? There's a 4 times x. I'm going to divide both sides by 4. Then I get 1x is less than 12 divided by 4. Should be 3. Let me double check. And yes, it is 3. So the thing you got to be careful, and this is for the whole page right here, right? All 4 problems. If you divide, remember the rule, by a negative, you flip the inequality. And I say divide or multiply. That's the rule you got to remember. Aside from that, it's basically the same as solving an equation, right? So let's see. I got x is less than 3. So where's my answer 3? There's 3, there's 3. So those are okay. That is negative 3. So that's wrong. That's negative 3. That's wrong. So does it go to the right or the left? So what you're going to see is, oh, Beltran, look, the x is first. So since the x is first, whatever direction the inequality points, that's the direction it goes. And that is totally correct. The other thing I personally like to do is I like to check 0. So I do that because then I get a little weirded out with when I flip them, or if the x is on the right, because then it gets confusing, because then you have to remember it goes the opposite. You see, it's extra. But if I always do this, I don't care about 1,000 extra little things. So here's what I'm talking about. I'm going to check 0. 0 has to work. So 4 times 0 minus 24 is less than negative 12. 4 times 0, this is why I love 0, it's just 0. So it just goes away. So in other words, is negative 24 smaller than negative 12? Is that true? Yes. So in this case, it worked out. So if it works out, you have to go in the direction of 0. And you'll see what I'm talking about in a little bit. I'm sure it'll happen in one of these. So here's my next one. Let's see. What do I check first? This one has to be open. So that's my first strategy. And this was awesome because it can't be B or C. Automatic. See? Those are wrong. And can you guess? My answer is either going to be 2 or 4. And I don't care what direction it goes. It has to go to the right. So let's see. Is it 2 or 4? Let's go ahead and solve this. So I'm going to subtract 4 from both sides. Those go away. I got 2x is greater than 4. And I'm going to divide both sides by 2. So then I get x is greater than 2. So where's my boundary point? It should be A. Okay. All right, next one up here. And everything is closed. Yeah, that is closed. So whatever. Okay. So there's only two options. Is it 2 or is it -2? Let's see. And then what direction it goes. So I'm going to, same thing. There's my wall so I can stay on both sides or deal with the sides when I say things like that. So what am I talking about? To me, when I say, how do I get rid of a -6? I put a +6. If I do it to one side, here's what I'm talking about. I'm going to do it to the other. Those cancel. So then I get -3x is greater than or equal to, otra vez, I'm going to have -12, +6. That's a -6. Do you see what's going to happen here? I just give you a huge hint. What am I going to divide both sides by? Whatever stuck to my letter. So in this case, the coefficient is -3. What did we say? If you divide or multiply by a negative, you got to flip the inequality. So if I'm dividing both sides by -3, that'll give me 1x still. But that has to flip going that way. And I get -6 divided by -3. Well, -6 divided by -3. And I get +2. So what's my answer? It has to be 2. So it can't be these negatives. So those are gone. What direction does it go? So here's the thing, right? If you had forgot, did you forget? And this is where this plays in perfectly, right? If you forget to do that, what direction would you have gone? You would have gone to the right because that was the original, right? So this is why I like to check 0. So let's see. And you can show right here because I was like this. My answer is 2. It is closed. Do I go to the right or left? I'm going to check 0. Question mark. Okay. So let's put the original over here. -3 times 0 minus 6 greater than or equal to -12. -3 times 0, it just goes away. Is -6 bigger than -12? Yes. So -6 is bigger. So in other words, did the 0 work? Yes. So from my 2, I should go to the left. Can you tell why I like doing this? Because even if I forget to flip it, if I check it, I will know what direction to go. Okay? That's why I do this. It's one less thing to worry about, guys. And again, it's just a habit, right? If you had me as a teacher, we did this all the time. You were annoyed at the beginning, but then you were so happy because it was way faster at the end. Okay? If not, then, something to keep in mind. All right, same thing right here. Everything's open. Notice I'm already seeing, right? I'm going to divide by a negative because I see a -5 stuck to my x. So let's see, two-step equation or inequality. I'm going to add 10 to both sides so that these go away. I got -5x less than, let's put it on here, -15 plus 10. And I got -5. Divide both sides by -5. And I got x is greater than +1. Now, normally, how would I graph this? I would go like this. There's my 0. There's my boundary point. It is open. What direction do I go? I'm going to check 0. So let me do this up here. Again, I don't need a lot of room. -5 times 0 minus 10 is less than 15. -15, sorry. The 5 times 0 goes away. So is -10 less than -15? Is that true? No. So I do not go in that direction. Do you see that? What direction do I go? Since I put an x there, I can't go to the left, which means I go to the right. And again, did you forget to flip the inequality because you divided by a -5? So which one has it at 1? That's 1. That's 1. It is not 0. Which one goes to the right? A. Okay, and more calculators, so I'm just going to leave that open. Sweet. Emily rides her electric scooter. She records her time and distance each time she stops for water. Okay. If Emily continues at the same pattern, how many miles will Emily travel if she stops after 180 minutes? So, in other words, we just got to figure out the pattern, no? So, is there a pattern going this way? Is there a pattern going down? Well, if I look at it, this is plus 6 plus 9 plus 9 plus 4. That's not a pattern, okay? So that doesn't work on the right side. On the left side, I can say plus 18. I don't know what that is. I'm going to check right here. 63 minus 36 is 27. What the heck? What about multiplication? 18 times 2 is 36. 36 times 2, what does that give me? It's 70. No, that does not work. So that doesn't help me, going up and down. Is there a pattern going left or right? Well, the first one, I'm going to go to the right, because it's America, I would say. It's America. We go to the right, left to right. So how did I get to 16? Well, I could have subtracted 12, but subtracting 12 to the 36 doesn't work either, because 36 minus 12, I think, is too far. Yeah, it's too far from 12, so that's 24. So that doesn't work. What's the other way I can shrink it? Well, instead of subtracting, I can divide. So 18 divided by what is 6? In this case, I think it's 3. Let me double check. 18 divided by 3 equals 6. Yeah. Does that work for 36? Well, let me check. 36 divided by 3 is 12. Hey, that works out. Is that the same for everything? 63 divided by 3. That's 21. Oh, not 21. Divided by 3 equals 21. 90 divided by 3. So I assume these are going to work now. It's 30. And 132 divided by 3, just to make sure. Divided by 3 is 144. So why do I care about that? Because I have to put 180 minutes. And 180 minutes goes on the left side. So this is 180. How do I get the miles, aka the distance, right, that she traveled? So I'm going to take 180, divide that by 3, and I'm going to get my answer. So let's clear this. 180 divided by 3, and I get a total of 60. Awesome. So it's a little bit of work, right, to do, but it's not that horrible. And once we got the pattern, then we were good, okay? By the way, I noticed this a lot in 6th grade, right? In 7th grade, I gave my 6th graders a hint, right? A lot of your tables, and I don't know, I haven't done the other videos yet, but a lot of your tables end up being like, how do I go from X to Y? I usually had to multiply, or I divide it. And notice those are connected, right? I can go back and forth. So instead of, what I mean by that, like, well, how do I go this way? I could have said times 3, right? 12 times 3 is 36. 21 times 3 is 63, and so on. All right, just a little hint, right? 6th and 7th grade, that's usually the pattern. All right, enter the equation. This is a two-parter. I didn't even see that. Okay, so enter the equation that represents the relationship between M. So super important. Equations means you better put an equal sign. Relation between Emily's distance and the time she stops for water. Use D. So you better have D. You better use an equal sign. And you better use T. Now what's missing usually is numbers, right? So this is what I have so far and what I know I have to use. The other thing is, what numbers do I use? Well, technically speaking, I have a bunch of numbers right there. So let me see what equation I'm going to use, and this is kind of my hint, okay? You just got to look at the table. And usually I go left to right on the table. So on my table, I started with time. You see that? I started with time. To get to distance, aka to equal 6 or equal 12 or equal 21, I took the time and I divided by 3. So I took time, divide by 3. Then I got my distance. So do I have what I need for my equation? Do I have D? Yes. Do I have an equal sign? Yes. Do I have T? Yes. And in this case, I also got a number right there. So you could have said, and again, depending on your keyboard, you could have said t divided by 3 equals d. Or you could have said t, because again, there's a fraction button usually on your keyboard like that. You could have said t over 3 equals d. Or you could have said time equals 3 times d. Any of those would have been okay. Those are all equivalent equations. So whichever one of those you did would have worked out. And again, I usually go with my first ones because I go from left to right. And it's easy, especially when you have tables, to kind of do it that way. And when we get to one of these, I'm sure one of these quizzes is going to have a bunch of tables. I'll probably explain it the same way. Okay? It makes life a lot easier. I don't care what level of math you're in. Okay? Just a heads up. Hint, hint. All right. What is the next one that we have to take care of here? So let's see. We are on number 14. Okay. And we're almost done, right? Is this the last one? 14 and 15. Okay. Victor works at his family's business after school and earns, okay, I see money, $120 for 4 days of work. That is a rate. $120 per, not day, per 4 days. Okay, that's fine. He's doing a good job, and his parents decide to give him a 10% raise. All right, good job, Victor. So how much in dollars, enter how much in dollars Victor will earn each day after the raise. So, let me think about it. I got to break things down here, all right? So I care about each day, right? So if I know that $120 is for 4 days, how do I figure out how much you earn in 1 day? And to me, this is like ratios, right? Like if you're in my class from 7th grade, you hopefully remember this strategy. Because ratios are just fractions and blah, 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 and they're equivalent and blah, blah. Okay, anyways. So this is a question mark, right? Well, let's think about it. To go from 4 to 1, I divided by 4. So if I want to find how much 120 was, well, I'm going to divide 120 by 4 days. So if I use my calculator, 120 divided by 4, that equals 30. So does that make sense to you? $30 per 1 day. Let me triple check. I got 30 plus 30 plus 30 plus 30. Is that 4 days? Yes. Did that give me 120? Yes. So that makes sense to me. I'm making $30 a day. Now let's get back to what happened. I am doing a great, or Victor, I keep thinking it's me. Victor is doing a great job. And Victor is going to get 10% raise. That means his pay is going to go up. So now the question is, what is 10% of $30? This is something I know for sure in 7th grade. We saw this so many times, guys, and eventually you guys learned a little pattern, right? You learned that the word of basically means to multiply. And the thing that's crazy, this calculator, I didn't even know, okay, because we don't use that often in high school, but it has a percent button. And look at what happens if I press a percent. It says percent of. So if I clear that, I'm going to put 10% of 30, and that equals $3. Now what really happened was, okay, one of the shortcuts you'll learn if you were in my class for 7th grade, is you're technically saying 10% times $30. And 10% we got to change to a decimal by moving it to the left twice. So 0.10 times 30. And let's see if we get the same thing. 0.10 times 30. And yes, I got $3. So the thing that's tripping me out here as a student and as a teacher is that I've never seen it do that, the decimals. But again, I've never really played with it. Most of the other calculators, they'll just be like 30%. It will not say the word of. So I don't know if you could expect that on your test, okay, on your state exam, but it's on this one, and supposedly they're the same. So just a heads up. If it doesn't say of, just know that that means you have to multiply. So normally you can say 10% times 30 on a calculator. Okay? So just a heads up. If not, it'll say of 30. Same thing. So what do I do with that? Okay, let's read the question one more time. Enter how much in dollars he will earn each day. So he's not earning $3, he's earning $3 extra. So if he's doing $3 extra plus 3, so you're talking about $33 per day. So not bad, okay? All right, and the last one. Oh my God, every time I see this, I know I'm playing teacher, most likely. Which statement identifies and explains the first mistake so that Drake made? Drake is wrong. Again, I'm thinking about another video I did earlier where one of the options was no. They would have been like, Drake is right. And I'm like, oh, I've had so many students put that. I'm like, dude, it literally says that the kid was wrong. You can't put that he was right. Okay, it didn't ask you if he was right or wrong. It told you. So this one says he's wrong. All right. So what I hate about these questions is that they all sound the same. One of the things I want to check, though, is usually at the end of these, well, sometimes, they'll give you the answer. And notice in this one, I don't get answers at the end. They usually be like, oh, it should have been blah, blah, blah. It should have been blah, blah, blah. It should have been. No, this one doesn't tell me. So what am I going to do as a student? I'm just going to go ahead and do the work myself. So I'm going to have 2, 3 plus 4x minus 5. Okay, so notice that's step 1. So you can't screw up step 1. They copied it correctly. And trust me, I've seen step 1 be wrong because they copied it wrong. Okay, they forgot to put a minus 5. They put a plus 5, for example. Okay, so what do I normally do when I see parentheses? I have to distribute. So this is me as a student. Okay, I'm going to do 2 times 3. That's 6. Then I'm going to do 2 times 4. That's 8 x's because there's an x there. And 2 times negative 5. Do I have a calculator? Yes, I do. So I can check my work just in case. 2 times negative 5 is negative 10. So there's my second line. Is that the same? I have a 6, I have an 8x, and I have a minus 10. So that one is true. So it can't be that one or that one. So it's either C or D now. All right, what's the next one? Well, now I got to combine stuff. So 6 with negative 10 and x's with x's. Well, there's only an 8x. I'm going to leave that alone. So now I'm going to say, okay, x's always go first. Numbers go at the end. So 6 minus 10 equals negative 4. So here's the kicker. My next line should say 8x minus 4. That third line does not say 8x minus 4. Do you see that? Can you tell what they did, though? So can you see what they said was they're going to keep this one and this one together, and then they put the 8x at the end. Here's the problem. What kind of 8x was it? It should have been a plus 8x. And what did they get? A negative. So either way, step number 3 is wrong. Okay? So when reordering the terms, the 10 should have stayed negative. Yes. Okay, that is true. The 10 should have stayed negative. And excuse me. And the 8x should have stayed positive. Yes, that is true. Okay. So step number 3 was wrong right there. Okay. And right away, can you see our final answer? Right? Final. It's different. So that's how we know they messed up somewhere. All right. Was that it for us? Yes, that was it. All right. So, quick recap. All right. Hopefully this one, you got this little strategy, right? We got to check the 0. It helps us, especially when the x is on the other side and they flip us. This is for those students, right, who are used to these harder questions and it's less to think about. Okay. This strategy, all right, did you get the hang of it? So notice 112, 112. I just got rid of the decimal 2 places, and there's my 46. Hint, hint. And a bunch of this is just simplify everything. Just do the work. Okay, it'll make your life a lot easier. All right, guys. Until next time.